Swayam Prabha. Digital India. Educated India.
Good day to all of you, and we will continue our discussions on liners for landfills. We started this discussion last time. We looked at the concept of composite liners. And we also said that we are not aware of any single material which can meet all our requirements of impervious base of a solid waste disposal facility. So let's have a quick recap of what we did last time, and then we'll take it on from there. Just to remind that the liner is at the bottom. If you have a below ground landfill, the liner is the main component, cover is less. If you have an above ground landfill, liner is less, cover is more, and on a side slope landfill, these may be of similar order. And after our discussion on various materials, we said this is what we nowadays accept as an acceptable hydraulic barrier. A geomembrane, thick geomembrane, and an low permeability soil. It can be natural clay in that area. It can be clay imported from an outside area and compacted, or if you have in situ soil to which you can add commercial clay, any of these, if it gives less than 10 to the power of minus 9 meters per second as the permeability, and it must be thick. So this is anything which is thin can be punctured, can be torn, can crack. You say, I don't know, I will use a clay which is 10 to the power of minus 10, but I will use it 1/10 of this 10 centimeter thick clay. That means I will have this much clay. Fine, you do have this much clay, but when it settles, is it going to crack? Is it going to get a preferential pathway? So you need a thick, a 1 meter, a 1 meter, a 2 meter. So you need thick and a thin impervious thing on the top. And we said intimate contact is essential. If you do this, the composite barrier doesn't work. And we talked about single liner systems, only one element, not used for landfills, except sometimes for C&D waste. Because C&D waste are often termed as inert. But they are used in canals, ponds, and lakes. Single composite liner system, the one which we have seen just now, is used in municipal solid waste landfills. And I just want you to understand the word liner system and the word barrier that I use. Typically, what is at the base is called a liner system. So it will comprise of the leachate collection system also, as well as the barrier system. So it's the whole thing put together. In some books, they will only talk about the barrier system as the liner system. So it's a terminology which is not rigidly fixed. When I use the word liner system, I normally include the leachate collection and the barrier at the bottom. So I'm talking of a single composite liner system. It will have a composite barrier layer. Double liner system is distinct from double composite liner system. And a double liner system, you put an underground petrol tank, and the regulatory authority says, I want to know if it leaks. So you said, okay, I'll put a double walled tank, inside steel, outside steel, or inside polymer, outside polymer. And when it leaks, I'll get liquid in the airspace between the two. I can tell you that it is leaking. Not acceptable for landfills. Only a double composite liner system is acceptable for landfills, because you can take out an underground drum and you can repair it, but you can't take out a liner of a huge landfill which has been covered with a lot of waste. So the double composite liner system has a primary composite liner system and a secondary composite liner system. So it will have two elements, a leachate collection layer and a primary barrier, then another layer where the liquid can travel, and a barrier. So the secondary system is called the secondary leachate collection system. It is also called the leak detection layer. Just like I gave you the example that you have a double wall drum, then the outer wall serves to tell you whether leakage has occurred or not. Similarly, in a double composite liner system, you'll have a leachate collection layer at the top, which will take away most of the leachate. If something comes through this, it will come beneath it. The moment it comes beneath the clay of the primary barrier, that is leakage. So you need another sand layer or another drainage layer which can detect that leakage. So that is called the secondary leachate collection system. That means whatever comes through, you will take it out, but it also is called a leak detection layer. And we talked about this last time. Waste here, a drainage layer. So I've depicted it with sand and gravel with some pipes inside it. This is the leachate collection system. This we'll look at later. We are at the moment talking about the barrier layer. This is a single liner with a single barrier. If you just go from here to here, you now get a dark line. So that's a composite barrier. The geomembrane plus clay, thin plus thick. There's another dotted line here. We'll come to that a little later. It may or may not exist. And if I just go from here to here, I have two of these composites, 1 and 2. This is the primary system, this whole leachate plus barrier, and this is the secondary system. And this layer is often also called the leak detection layer. What is the difference between the top one and the bottom one? This can handle more liquids. This will handle less liquids because leakage is going to be very, very small. Any confusion on this? No. Remember, for a system to be a double system, you have to have an air gap, or you have to have a drainage layer between the two. Sticking two things together doesn't make it double. Otherwise, then you will say, sir, this is a double system. This looks like a double system. One liner and another. Isn't that right? But this is not a double liner. This is a single composite liner. If there's an air gap between the two, then it becomes a double liner system, but not a double composite liner system. So this is used normally for C&D. You may have clay, or somebody may choose to have a geomembrane alone. This is used for municipal, and this is also sometimes used for hazardous waste, but the thickness of the clay is very large, and this is used for hazardous. So if I look at the specifications in the Indian environment, that is the Central Pollution Control Board and the Ministry of Environment and Forests, this is the waste. It says that the leachate collection layer should be a 30 centimeter thick sand gravel layer. That's it, a sand gravel high permeability layer. And the base of the landfill should always be tilted to one corner so that all of it can flow to a sump like a bathroom drain, and there it can be collected. In this, there are perforated pipes. Sometimes you may need them, sometimes you may not need them, but the idea is they should be able to carry the whatever leachate comes and allow a easy passage. Beneath that is a 1.5 mm HDPE geomembrane. So now there are these issues about what is HDPE, why not PVC, why not PET. PVC is polyvinyl chloride, HDPE is high density polyethylene, PET is polyester. So there are different kind of polymers that we have. But at the moment, for this course, you will have to accept that HDPE is the most chemically resistant polymer. And then I have the subsoil. So this is for municipal solid waste, so prescribed by the Central Pollution Control Board or the Ministry of Environment in the hazardous waste management rules. Okay. For the for the municipal solid waste management rules. Did I say hazardous waste? Well, the municipal solid. If I have hazardous waste, I'll have two systems. It looks like this and it looks like this. So I'll come back to what is what, but this is a single composite liner. In the single composite liner, we are back to this 30 centimeters at the top. This is a universal thing of sand and gravel. Here you can see a permeability value written for you. greater than 10 to the power minus 2 centimeters per second. Is it visible? Generally visible? Maybe the ship in future, you should come up a little closer if you are not being able to see from there. I won't pass an electrical current from here. I can assure you about that. Right? Okay. What is the difference is that suddenly this has become bigger. So this is more than 1.5 meters thick. So this is derived from the European practice, and this is for hazardous waste. And in Europe this can be even bigger. And once you have only a single composite liner, there are stringent requirements of the subsoil. In the sense, they say that you can put your landfill on a subsoil which will have a permeability less than XYZ, right? So they wanted, you may not sit on clay, but they will give you then you can use a thick clay, and this is a single liner system. Let me come to the next one. Repeat, this is a single composite liner for a hazardous waste landfill. And this is a double composite liner. Waste, 30 centimeters, primary leachate collection system, 10 to the power of minus 2, greater than 10 to the power of minus 2 centimeters per second. Clay, compacted clay, greater than 45. I prefer greater than 60. We'll come to that later. You can tag this point. I prefer 90. Then a secondary leachate collection system. Again 30 centimeters. But what has happened to the K? Here the K acceptable was 10 to the power of minus 2. It had to be greater than that. Here it is 10 to the power of minus 3. So this may be a gravel sand mix. This may be a coarse sand. You can have a soil with not as high a permeability. It's not going to handle that much leachate. Bulk of it is going to be collected here. And then again another composite liner. Any questions? Purely from constructability point of view, this 45 centimeters should be larger, but this is the minimum specification. This is not a design specification. It means whatever you design, you can't be less than this. For a geomembrane, it can be 2 millimeters, it can be 2.5, but it can't be less than 1.5. And most of these things come from construction rather than from design issues, because nothing should tear or puncture during construction, so 1.5 mm may be the minimum required for HDP. So when do you have a double liner system for hazardous waste, and when do you have single liner system for hazardous waste? Well, when the risk is clearly higher, you go for double. Okay? Well, when you have hazardous waste, you would tend to go for double or single. But when you have municipal solid waste, which is non-hazardous, you go for single. It's rare to have a double liner for a non-hazardous waste. When is the risk higher? When the water table is shallow, it's closer to the base. So you have a hazardous waste, shallow water table, subsoil is pervious, you're sitting on sand, and precipitation is high. It's raining all the time. More leachate. So this, in fact, predetermines when you will use a double system. So and when a drinking water source is nearby or very near, I mean your landfill is sitting next to a bunch of tube wells or pumps which people are using for drinking water, then you want to know when your landfill is leaking and whether it needs to be remedial action. So when you have wells or a lake doesn't get washed every year, unlike the river, where in the monsoons you'll have high flows. So this is all high risk, so you'll go for a double. And some regulatory authorities require 100% leakage detection. So how do you detect leakage beneath a single composite liner? I can detect leakage if this is the base and my landfill is above the ground. Not only is it above the ground, it is clearly 3 meters above the ground. I can detect this visually. I can walk every day and I can detect it. But if I put a sensor here and say, okay, I'll put a moisture sensor here, can I detect leakage? If I put a sensor here, let's say that round thing is a sensor, will it detect leakage? Yes or no? Because the water content will go up. So, but my problem is a single sensor won't detect it, leakage will be taking place there. So how do you detect leakage? So I'll put a sensor at every 1 foot, still I may not detect it. How many sensors will I put if I am putting it at every 30 centimeters or a meter? I'll put hundreds of sensors. So then I need a continuum. What do I say? I'll put another layer underneath it so that when the drop falls on it, I can detect it. And it will detect because it's slightly sloping, it will come to one side. So a double composite liner system is in fact 100% leakage detection system. We can make sporadic locations of moisture detectors underneath a landfill base in soil, but it cannot detect if the pathway is somewhere else. So if your regulatory authority says no, in America they say, what's the difference between European practice and American practice? In America they say, I want to know when it leaks. So for all hazardous waste landfills, you will have a double composite liner. In Europe, they say you must have a very thick, low permeability soil beneath the clay. So they are forcing you to select a particular type of site. Are you getting? You cannot go and put it your landfill at every location. And they'll say the water table has to be so much deep. In India, where do we find low permeability soils on the ground, and where do we find high permeability soils on the ground? If you look at the top on the map of India, are you aware of the soils of India? Great. So which part of the country has got low permeability soil? Himalayas are all rock. Somebody said in the Himalayan range, I think all Himalayan slopes have exposed rock or a little bit of soil at the top, which is weathered soil. Where do we get a lot of clay? Maharashtra, Gujarat. Anybody else? Maharashtra and Gujarat. What is peculiar to Maharashtra and Gujarat that they will have? Coastal regions will have. So you mean in the sea or just before the sea? Or where between high tide and low tide? Do you think you can put a landfill between high tide and low tide? Right. So I'm surprised that you can't answer this. Wherever there is black cotton soil, wherever there's black cotton soil, and there's a lot of black cotton soil in India. You're aware of the word black cotton soil? Swelling clays? So all I'm saying is a huge amount of area below the central part or within the central and below the central part of India, including the Deccan Plateau, has a lot of black cotton soil or has a lot of clay. The coastal regions have a lot of clay because the rivers have brought the fines and deposited it there. So you'll get marine clay at various locations. So you don't have to go into the ocean. Even several kilometers before that, you'll find Bombay clay, Bombay marine clay, Calcutta marine clay we'll have. And which part of the map do you see the high permeability soils? Desert. So in desert, luckily rainfall is low. So precipitation will be low. So leachate will be low because it's a desert. So, but yes, I mean, one place is the desert, you'll have dune sands, right? The high permeability. Any other place where you'll have high permeability? What are high permeability soils? Clays and silts and clayey silts and silty clays are low permeability. Sands and gravel and sandy silts are? So where are the sandy silts? Okay, so but we are not going to put a landfill in the riverbed. Again, just remember, we have something called the Indo-Gangetic Plain. The whole plain is alluvial, including Delhi where you are sitting. And what are alluvial deposits in the North India? In Delhi, in Meerut, in wherever, in Agra, what is the soil type? Well, if it's sandy silt, by Jove, it's permeable. So remember, the whole of the Indo-Gangetic Plain in the north of India is on pervious bed. May not be very pure clean sand, but if you have seen Yamuna sand, well, that's pure clean sand. But even if it has some silt, it is not a low permeability material. So that gives you the answer as to where you are going to get double composite liners and single composite liners for hazardous waste facilities. Another important issue is, I have shown these diagrams, and these do not have all the elements. These are the minimum requirements. Let me take an example. Let me look at this interface between the geomembrane and the coarse grained soil on top, right? What will be this coarse grained material? As I said, it will be sand or gravel. So where will you get the sand and gravel from? In Delhi, where will you get the sand and gravel from? Yamuna. Yamuna gives you coarse sand. If you have done the laboratory course, you would have dealt with Yamuna. And if you have dealt with Yamuna, please tell me what type of sand is it? Well, it's medium to fine sand. So that's not going to work. So you need to get coarse sand or gravel. And if you get quarried sand or if you get quarried gravel, then you will have angular particles which can damage this geomembrane. Why? You're going to put 30 meters of waste on top of this. Eventually it will start to puncture, indent into the... So you might need to put another layer here to protect this geomembrane from puncturing. So I'm saying all layers are not shown here. And you may need a filter, you may need a separator, and you may need a protector. And I would like to tell you that each interface which has been put in the minimum guidelines by the Ministry of Environment and Forests and the Central Pollution Control Board requires that it be examined for, does it need a filter, does it need a separator, and does it need a protector. So what in your opinion is a filter? So what do you mean by the word filter? Pardon? What allows the passage of water is a filter. So everything is a filter? Sand is a filter, gravel is a filter, cobbles are a filter, and what is the other component for it to be? So if you allow passage of water without allowing passage of soil, that's a filter. So it must be pervious. It must be pervious enough to allow passage of water, but it should not be so pervious that the fines are also washed away with the water and you get muddy water through the soil. So that's a filter. What's a separator? Where is a filter used normally in geotechnical applications? Where is a filter used very commonly? Where? In a dam, yes. Between what and what? At the toe of the dam. I'm not sure I've seen a filter at the toe of all dams. But yes, it is sometimes used. But is there any other location? What is it doing at the toe? What's a filter doing at the toe of a dam?
To prevent the particles beneath the dam, soil particles beneath the dam to flow.
So now you're talking of beneath the dam. Now that's even more complicated. Flow of soil particles from beneath the dam. Are you talking of a barrage which has a concrete flow, or are you talking of a dam? Suddenly you have changed that. I said, where do you want a filter? You said at the toe of a dam. Now you're saying no, a barrage. Are you still firm with your toe of a dam?
Yes, sir.
It is used in both toe of a dam as well as a barrage. So are you talking of a rock toe at the toe of a dam? Because I think I know of a rock toe at the toe of a dam. Maybe. So in any case, what we are saying is, when we put coarse grained material in contact with fine-grained material, we don't want the fine particles to move away. So in all dams, between the core of the dam and the shell of the dam, we have what is called a transition filter. And the idea of a transition filter is that the fine particles of the core should not travel into the shell. That's a clay core. Shell, and we have been designing transition filters such that when this water flows through this core, none of the fines get washed out at this interface, and that's called a transition filter. At the downstream of a barrage is an inverted filter. And what is the purpose of the inverted filter? It is similar. Water is coming vertically upwards because the barrage floor is impervious. If it will come vertically upwards, the fines will want to get washed out. So on that I put a filter so that I cannot have the fines washing out. So here also we have to do that check. What's a separator? A separator is something which keeps two soils separated and doesn't allow them to mix. A separator is one which keeps two layers separated and doesn't allow them to mix. A very nice example of this is when you put ballast of train tracks on soil, what happens? And where is there a problem? Now you have this natural ground and you're putting ballast. Ballast size, you know, is coarse grained, gravel and more. So what happens? If you have, for example, let your soil be soft clay and you put this ballast on top and then you put your tracks, what is going to happen with time? The ballast will tend to penetrate into the soil. So if you want to keep two materials totally separated, that's your soft clay and that's your ballast. Just an exaggerated view. So I don't want these particles, you know, over a period of time due to the trains passing on the top, mixing with the clay, because then the effective thickness of the ballast will go down. A separator is an element which keeps the two separated. And what is a protector? So I just now told you a protector is a layer which prevents damage to the underlying layer. A protector is a layer which prevents damage to the underlying layer. An example of protection. A riprap against wave action. You have a reservoir. You understand what is riprap? Okay, you have a reservoir or a lake embankment and you have water. And under high winds, this water will lap against the soil. So it will try and damage the soil. So how do you protect the soil from being eroded by the wave action? By putting large size material which will absorb the energy of the waves. So you put what you call riprap or pitching. Stone pitching, hand placed pitching. Still it will take away the fines because there are large gaps between the cobbles and the soil. So what do you need in between? Something which prevents the fines from coming out. A filter. So your stone pitching will sit on a gravel pack or on a sand gravel filter. So you will have smaller so that the fines cannot wash out. So inevitably we are talking of something protecting the underlying layer, right? So let's look at now we've got so many layers. many interfaces between the layers. Filter allows water to pass without fines of soils. Separator does not allow particles of one soil to mix with another soil across a boundary of an interface. Protector prevents puncture or tear or damage of the underlying material. The protector is a sacrificial layer. It is not doing any design. It's just a sacrificial layer. Agreed? So, where do you think you need these in our liner? Let me now come to our diagram. We have waste. Waste is not like an egg, it's just a representation. Unless tomorrow you say, sir, waste is like an egg. It's not. Waste is also horizontal. So let me make it correctly. I don't want you to. Waste is also a horizontal layer. Underneath the waste, what do I have? I have the leachate collection layer. And then beneath the leachate collection layer, I have a geomembrane, as I've shown you. Sand, gravel. And then beneath that, I have the clay. And beneath that, I have the local soil. Is visible to all of you? Is this visible? Yeah. Waste, leachate collection layer, geomembrane, clay. I have to look at each interface and I have to tell you, I have to see whether I need a separator, do I need a filter, do I need a protector. So should we start bottom upwards? Well, let's start bottom upwards, it's simpler. It's simpler. That's local soil, what we call subgrade. That is compacted clay liner, this is geomembrane, this is leachate collection layer or leachate collection and removal layer, and that's the waste. So many interfaces, 1, 2, 3. Are there 3 interfaces? Forget about the top, 1, 2, 3. But always look at the interface from below and always look at the interface from the top. So you have 2 surfaces, 2 sides of an interface. If you have subsoil and clay, do you need anything between the 2? Well, we have to check whether you need a separator or not. If the subsoil is clay and you're putting clay on it, is there a problem? If the subsoil is silt and you're putting a clay on top of it, is there a problem? The clay particles will not go into silt particles. They'll meet something called a filter criteria. If you're putting clay on sand, is there a problem? Could be. I need some criteria because now the voids are getting bigger. And if there is gravel and I'm putting clay on top, I can jolly well say when I put the clay on top, it will go into the voids. So whether I need a separator or not, somebody used the word protector. I don't need a protector for the underground soil. Even if it is soft clay, I need a separator. This is clear. So I need a separator. I may or may not require it. Therefore, it's not in the minimum guidelines. The designer has to decide. But I need to be very clear that I have something which has to be put here. So I'm just going to put a dash line and you can mark it as a separator. Optional. Separator is optional. And then let's look at the interface between the geomembrane and the compacted clay liner. Do you need a filter? Do you need a protector? Or do you need a separator between this and this? Geomembrane is plastic, clay is very fine grained, and if you put anything, you no longer have a composite liner. The intimate contact is an essential component of your liner. Do you need anything on the top? Between the sand, gravel and the geomembrane? A protector if you have angular grains, but if you have rounded particles, you may not need it. When will you get angular sand, coarse sand, and when will you get rounded coarse sand and gravel? Yeah, if you are close to a river and the river bed has got round cobbles, pebbles, coarse sand, gravel, you can use it, and typically that does not cause a problem. But if you have quarried material, it's likely to be angular. So again, you need a protector here, optional. You may need it, you may not need it. Is there another interface between the waste and the sand gravel? Do you need anything between them? A filter or a separator? Or both? I mean, I have not said that you need only one. You may design a filter which is hydraulically competent, but it may not be competent for a glass to cut through it. So you need a filter, definitely. Why do you need a filter? If you don't put a filter, still the flow will come down. Why do you need a filter? You said I need a filter. Just because I say you need something, you don't want to put it. So if you don't put a filter, what will happen? Waste particles will go into that. So you need a separator or a filter? We said if you want to prevent particles from one to go into the other, you need a separator. Yeah, so separator may allow the water to go through. So you need a separator and a filter. Please understand, what are we bothered about? We are bothered about the fact that the fines of the waste should not come down and clog the drain. That's like your kitchen waste in your kitchen drain. If you keep on putting your tea leaves, don't put them in the dustbin, but you keep on putting them in your drain, they will go and clog the drain. Similarly, the waste is heterogeneous, it will have some fine particles. If you don't have a filter, what will happen to the fine particles? They will gradually come down with the leachate. The leachate will wash off because it's inclined, but it will deposit those fines in the sand and the gravel voids. And the sand and the gravel voids, which started with 10 to the power of minus 2, will become 10 to the power of minus 5, and the leachate head will build up, and you will have a huge landfill sitting on a wet, sloppy, low strength material which can cause failure. And most of the landfill failures occur because of high leachate head. So you need a filter and a separator. Well, I'm not going to write this, but I want to put this here. So a filter and a separator. A protector. What do you? Separator and a filter. Suppose water is, leachate is coming through a geomembrane tear. We don't want it to stop it, because then the compacted clay will become soggy and saturated. It should be a separator, but it should also be a filter. Otherwise, a geomembrane can be a separator, please remember. But a geomembrane is also a water barrier. So we don't want water to accumulate in the clay. If you ever take a clay sample which is well compacted and saturated with the water, it will gradually lose its strength. So now, because of this, all that we discussed is written here. Between the waste and the leachate collection layer, between the leachate collection layer overlying the geomembrane, between compacted clay overlying the secondary leachate collection layer. If you have a secondary leachate collection layer at the bottom, it's gravel, in which case this is sitting over gravel, and you definitely need a separator and a filter, or if you are depending on the subgrade. You can use two things as a filter and a separator and a protector. We can use soil. So remember, traditionally we've been using soil. Our transition filters are made of soil. However, we have to apply a filter criteria. You remember the filter criteria? Let's try and remember it. We have a filter criteria which we do between shell and core. D15 of the filter should be more than D15 of the protected soil so that water can pass. So your filter cannot be less permeable than what it is protecting, then the water will hold in that material. So D15 of the filter should be more than D15 of the protected soil. But D15 of the filter is what is in front. It should not be so large that the fines can pass. That means the D85 of the soil behind, which is being protected, should be less than 3 to 5. This is the filter criteria that we have used for designing inverted filters, for designing transition filters. You've done slope stability and dams? You've done a course on dams? You're doing it this time? Right. So when you're doing dam design, please ask that this issue be addressed so that you understand the filter criteria. But the first criteria is that the filter is more permeable than the soil behind it, and the second is it is not that permeable that the fines can pass through it, right? So using this filter criteria, you can get the type of soil. So you can always put a soil filter between the layers. I have got a geomembrane and I am going to put angular gravel on top of it. What would you use as a protector that the geomembrane is not affected? If you were to use a soil, what would you use? In Delhi, I want to put gravel as the drainage layer, and I can only get quarried gravel. So I get it quarried, it's angular. I'm worried about my geomembrane. What would you do as a protector? I put Yamuna sand, fine sand. Fine sand particles are fine, it's rounded because, or sub-rounded because they are riverbed material, they would not puncture the geomembrane. So there is a traditional material which is available. You may, how much will you put? Maybe only 15 centimeters. 10 to 15 centimeters, you'll just put a layer so that when you dump the gravel on top, it should not damage it, and when the load comes, it will be distributed through those fine particles. But you have other alternatives also. So if I am to look at what do I use as filters and separators, I can use a material called geotextile, or I can use soil layers. The soil layers are 15 to 25 centimeter thick. They have a specific grain size and can function as filters, separators and protectors. Geotextiles are something that you will study in your course on geosynthetics. But in a very coarse way, they are like blankets. Thick blanket, not a quilt, a thick blanket. Now if you have a thick blanket, blanket is pervious, but you can so design it artificially that its fines will not go through it, but water can go through it. So you can use geotextiles as separators or filters and protectors, but there is a design involved in it. At the moment I have used two words here, you can note them down. They are normally you are using non-woven geotextiles and 400 GSM is, their weight is 400 grams per square meter. I mean, it's kind of an indirect indicator of the thickness or the strength. The more the GSM, the more the strength. So just to finish, this is what our liner will now look like for a municipal solid waste. This is what a liner will look like for a municipal solid waste. I have waste, then I have a filter oblique separator. It can be geotextile, GTX for geotextile, or it can be soil. Then I have my drainage layer or leachate collection layer, sand and gravel. Again, I have a GTX soil protector. I have my geomembrane. I have my compacted clay liner. I have another filter oblique separator of GTX and soil, and then I have my subsoil. So 1, 2, 3, 4, 5, 6 components of a liner system for a municipal solid waste. Single liner. If you have double composite liner, many more. This is the natural soil which exists. This is the waste we are going to put. 1, 2, 3, 4, 5, 6. Is that right? So we'll stop here and carry on in the next class about liners for municipal solid waste landfills. Thank you. Any questions? You're welcome to ask. No questions? All right, we'll take it on from here. Thank you.